everyone, I'm Ishita Jen from Fun to Learn, and today we are going to be learning about elements and compounds, which are basically pure substances. So let's go over the table of content, which is basically everything we are going to be doing today in today's video. We are going to have a little recap on what we already know on matter, and then we are going to see the categories in which matter is divided into. Then we're going to learn about pure substances, and then we're going to slowly walk in to the type of pure substances, which is elements and compounds. Then we're going to learn about elements, and then the isotope of elements, the periodic table, the periodic law, and compounds. So let's start off with everything we know about matter. We know that matter is made up of mass and occupies space. So anything that is made up of mass and occupies space is matter. But we know that matter is made up of mass. But what is mass made up of? Mass is made up of tiny particles called atoms and molecules. Molecules are basically bonded atoms. And we have already discussed this in our previous chemistry video called Atoms and Molecules. And if you guys haven't watched that yet, I would be pleased to send the link in the description box below. And you can check that out before you watch this. Now let's learn about the categories in which matter is divided into. Matter is divided into pure substances and impure substances. But today we are going to be focusing on the left hand side of this mind map. So basically pure substances, elements, and compounds. And then in the next chemistry video, we'll be learning about impure substances, heterogeneous mixtures, and homogeneous mixtures. So let's get started. Pure substances is basically any substance that is made up of only one type of particle. And that one type of particle can be an atom or a molecule, as long as we have the same type of particle throughout the substance. For example, if we have an oxygen atom, if we take an oxygen cylinder, if we take an oxygen cylinder and scientifically look inside, then all we can see is oxygen atoms. We can't see anything other than oxygen atoms. We won't find a hydrogen atom in there. We'll only find oxygen atoms. And if I take water and I scientifically look inside that glass of water, I can only see H2O molecules, only water molecules. So as long as only one type, I didn't say only one, if there's only one molecule in that water, then the quantity of your water is basically too less. And if you have 2 gallons of water, then even if you have, the quantity doesn't matter in pure substances, only the quality. So as long as it's only one type of particle, only one type of molecule throughout, then you're all good. But if you have some impurities, like if I take a piece of jewelry and I scientifically look in that, I can find some bronze, some copper, some gold, but I can't say that this is pure gold. It will always have impurities in it. Now let's talk about elements. Elements are the purest form of a chemical substance and are composed of only one. Yes, only one type of atom, not one type of particle, because that particle can be a molecule or an atom, but in elements, only one type of atom. These are some of the examples of elements, which is basically oxygen, hydrogen, and nitrogen. So I'll explain nitrogen here. This 7 number over here It's the atomic number, and the atomic number is there on each element block so that it's easy for the scientist to actually arrange it in the periodic table of elements, which I will show and teach you about in a little bit. Then we've got the symbol N, which represents nitrogen, and if some people don't have the symbols memorized, then they can always refer to the name over here, nitrogen. And then here, 14.007 is the atomic mass. The atomic mass or the atomic weight, whatever you want to call it, of nitrogen. And then this follows throughout all of the elements. Now we're going to learn about the isotope of an element. If the numbers of protons changes, it becomes a different element. Example, an atom with 2 protons is a helium atom. Now, by reading this, you wouldn't understand that much. So if I have, as I told you before, the atomic number represents the number of protons or electrons in a atom. So if we take a hydrogen atom, we have only 1 proton in it. But if I add another proton to the nucleus, it becomes 2 protons because 1 plus 1 is 2. And if it has 2 protons, the atomic number becomes 2. And if the atomic number becomes 2, then it becomes helium. So that's basically what this statement is trying to say here. But if the neutron changes, if the number of neutrons changes, it becomes a different isotope of the same element. Why doesn't it get any charge or anything? Because neutrons do not carry a charge. Electrons have a negative charge, protons have a positive charge, and neutrons don't have any charge at all. They're neutral, and because they're neutral, they're called neutrons. So if the number of neutrons changes, it becomes an isotope of the same element. Isotope doesn't really mean anything, it's just a term we use. For example, if I have an hydrogen atom, hydrogen doesn't actually have any neutrons, but some hydrogen atoms have either 1 or 2 neutrons. So if the number of neutrons changes, it becomes a different isotope of the same element. Now let's learn about the periodic table because you understood elements. Now you're probably curious, where can we find all the elements? Or you probably know about this because you have an older sibling. So let's learn about this too and impress them. So the periodic table is basically a table in which the chemical elements are arranged in order of increasing atomic number. As I showed you and gave you the example of nitrogen. Nitrogen had the atomic number 7. So after nitrogen would come the atomic number 8, which belongs to oxygen. So this is basically how they arrange the elements in the periodic table. It depends on their atomic number, and their atomic number doesn't go in descending order, it goes in ascending order. Now let's learn about the periodic law. The periodic law, which was discovered or made by a great scientist named Dmitri Mendeleev, was that the physical and chemical properties of the elements are a periodic function of their atomic number. Now, what does this mean? This means that, okay, let's start off with the first thing. We all know what physical and chemical properties and changes are. Physical properties or changes are basically luster, the burning of something. Because if I burn a piece of paper, it turns into ash, right? But that would be a chemical change because the composition is changing. But if I freeze some water, the properties changes, but it's still water, right? So basically, the physical and chemical properties are the change of composition, the state it is present in, and all that. And those properties and changes depend on a element's atomic number. So an element's atomic number is really important because it tells the element what your physical and chemical properties are. It represents the number of protons and electrons in an atom. It is in control of how the elements are arranged in the periodic table. Is really important. So we love your atomic number, and we will always be thankful of you. I hope the atomic number heard that. So this is the periodic table of elements. You might have seen this before, and if not, I'm showing you this right now. So we have 7 horizontal rows, and these 7 horizontal rows are called periods. And then we have 18 vertical columns. These 18 vertical columns are called groups. Now you might be thinking why these two rows are kind of separated from the table. These two rows are actually lanthanides. You might not learn about this right now, but don't worry, we'll discuss this in our one of our future videos. So right now we just need to know this, and some of the groups are famous here. As you can see, they are separated in different colors based on what they are, whether they are noble gases, whether they're halogens, whether they are rare metal, rare earth. um, it's really actually separated in a very nice and easy way for us to learn. So this is actually the noble gases, and noble gases are the only elements that are stable in nature. And that is why these noble gases do not bond with anyone. They do not bond with anyone. But these other elements bond with each other to become noble gases. For example, let's find oxygen. This is oxygen, right? This has the atomic number 8. It's not really visible right now. And then we have fluorine, neon. Neon has the atomic number 10. And oxygen wants to be like neon, and to be like neon, it needs the atomic number 10. So it bonds with hydrogen, but hydrogen only has 1 as the atomic number. So it bonds with 2 of the hydrogens. In that way, so 8 plus 1 is 9 plus 1 is 10. That way it becomes stable in nature. And in the same way, you might have seen H2. When you say hydrogen, we write it down as H2 because in order for hydrogen to be stable in nature, it needs to be like helium. So for that, it needs another atom, so it bonds with itself to become helium. Now, why only helium? Why can't hydrogen try to become like neon? Because the elements only try to attain the properties of their nearest noble gas. And I'm quite sure this might be clear. And if you want, we will discuss more about the periodic table in one of our future videos. Now let's learn about compounds. It's enough about electrons. Now let's learn about compounds. Let's give it some importance too. Compounds are considered a pure substance as they are made up of only one type of molecule. Now, we learned that pure substances are made up of only one type of particle. Now, that one particle can be either atoms or molecules. It depends on what it is. So, we learned that elements are made up of only one type of atom, but compounds are made up of only one type of molecule. For example, salt. Table salt, which is NaCl. Na represents sodium. Cl represents chlorine. So when Na, when sodium, when sodium when a sodium atom bonds with a chlorine atom, it forms NaCl, which is nothing but our very famous table salt. You can't live without it. Another very famous example is our water, something that we drink every day, H2O. And when these two hydrogen atoms bond with the oxygen atom, they form a water molecule, an H2O molecule, and hence these are compounds. Now, I just want to say thank you for watching this video. I hope you all understood what pure substances, elements, and compounds are. And once again, thank you. If you like this video, please share this video with your friends or somebody you think that needs help in this certain subject. And if you want us to record any other video or any other video on your topic that you don't understand, you can mention that topic in the comment section below and we shall get to you and make that video for you so that you understand. Once again, thank you for watching, and if you like this video, please, please hit that like button, and if you're new to this channel, then subscribe to this video and hit that bell icon, which is the notifications button, and if you hit it, nothing will happen to you. You'll just be getting notifications every time we upload a video on YouTube. So if you like this video, hit that like button and we'll see you all next time. Goodbye!